Okay, so I've gone through and I've added a few more voids. So if I take a look at my program, I've got a void for flashing, a void for sweeping, so that's the lights going back and forth. I made a Night Rider light that pulses from one side to the other, a bit bigger on that code. I've got a code for them all to be on and have a pulse go through. And I've got a bike light where it just flashes. That's cool. I've got a bunch of functions that I can use. Now, so far everything that we've done has been passive. There's no inputs that our program is looking at. So it's time that we take a look and add an input to our program. I'm going to come down here and we can go to components now and we can find something to use as an input. Now we should have a button. So we've got two push buttons we can use. So we're going to grab a push button and put it down in our program. I'm just gonna, we don't need this right now, so I'm just gonna, okay, so I've got my button. And now for the button, because it's an input, we need a voltage that's gonna go from the button back to the Arduino. To do that, we're gonna have to take a look at the 5-volt line on our Arduino board. So you can see I've got 5V there for 5 volts. I'm going to have to take that and I'm going to wrap it around and put it into the positive rail down here. Today I am playing with bendy wires. There we go. I'm going to make this red because it's a positive line and you always want your positive lines to be red. And now I can come from here and I can tie it all together. Now I've got my Arduino Sample open. From the Arduino website. Tons of examples here. So if there's something you want to try that you haven't done yet, just take a look at learning on the Arduino site and you can see a bunch of different circuits and they go into how to program them, what the schematics look like. So you can play around with this a little bit too. But on this diagram that they've showed us, I've got 5 volts going to one pin and a 10K resistor going to ground from the other side. So I can add that in here. So I've got my 5 volts. So I can just go from here to here. Now I'm going to make this wire red because it is a 5 volt. And then they had a 10K resistor. So let's grab the components. There's my resistor. I'm going to take the resistor and just, let's close that for a second. And I'm going to rotate the resistor just to make it a little cleaner on the board. And it was a 10K resistor, so 10 kilo ohm. And then they had that going to ground. So I'm going to bring that to ground here. And I'm going to make that a black wire. Now, I haven't actually connected this ground to this ground yet. So I'm just going to grab a wire from here to here and connect those grounds, make that black. So now I've got ground coming from here, back around, through that, this is called a pull-up resistor, to the button, back to the 5 volts. Now the next thing is I need to be able to read my button at the Arduino. So I'm going to grab a wire from the pin up here and I'm going to bring it down to one of my Arduino pins. And we're crossing there, which don't really want to do, but that's okay. I'm just going to put it in pin 3 and I'm going to change the color to something just so I can see I've got outputs are green. Now my input is blue. Let's make that a little darker. There, just so you can see the difference. Not that it matters, it can be any color other than red and black. So now I've got my button brought into my program here. If I go back to code editor, I can start writing program for my button. I'm going to go right back up to the scope to start. So I've got my integers. I need an integer for my button. So integer button equals 3 because I plugged it in 3. And we're also going to make an integer that's going to be to record the value of the button. So the button only has 2 values, on or off, but I still need to have something for that. So what I'm going to do is I'm going to say integer button value equals 0. So when the program starts, the button's value is going to be 0. Notice how I made a capital V in the middle? You'll notice that as a trend when you're going through the different lines. So I've got pin mode, digital write. That capital letter just signifies that it's a new word starting. So button value equals 0. In my pin modes, I need to assign a pin mode now to that button. So pin mode, and we can make button an input. It's not an output anymore, it's an input, because we want a signal coming in from that button. So now I've set it up in my scope, and I've set it up in my void setup. Come all the way down to our void loop, where I've got nothing right now, and we can take a look at the button. So I've got button value. So first thing, let's assign button to button value. So button value, double check. Oops. Button value equals digital read button. So now I've said button value, that value that was 0 is now equal to digital read button. So it's going to take whatever the button is and assign it to button value. We'll upload and run just to see if it compiles, but really I haven't said to do anything yet, so nothing's really going to happen there. If you take a look at the sample, you can see how they've gone through and done it. So in theirs, they've got button pin, they'd use button state instead of button value. And yeah, button state equals digital read button pin. It's the same sort of idea that they've got going on in theirs. You could do it this way, you could do it the way I just did it, same thing. The next thing that they've done is they've used what's called an if statement. So we're going to do the same principle. We're going to do if something happens, so if button state is on, do this. Else, do that. So if I come back to my code, stop simulation, I can say if button value, oh, we need to put this in brackets, sorry, my bad there. If button value equals high, like so, then do what's in the bracket. So it's its own little function. So if button value equals high, then let's say I'm going to turn on my bike light. Bike light, and let's say 1,000. And I'll finish that with another bracket. So now if my button value is high, the bike light's going to turn on to 1,000. Else, and I could have a different function going. So let's just, what else do I have here? I've got my all on function. I'll try that. Else all on, and we'll say 500. And we close that off with a bracket. So if button value is high, do this, else do that. Now, obviously, we could have wrote if button value equals low, but this should work the way it is. Upload and run. So we're flashing. Okay, flashing. Apparently I've made a mistake somewhere. Okay, so what could we have done wrong? Let's take a look. I have a feeling what the issue is that the scripting around this button is a little bit funny in 123D. So what I'm going to do is I'm going to take this wire that I've got hooked to the pin here, like the Arduino example. If we take a look at the Arduino example, you can see that they've got it hooked up like that, which is typical for how this should work. And I have a feeling what they've done is that they've got it hooked up so it has to be grounded on this pin. So, goodbye wire. And we're going to grab another wire from this pin here. So it's just a little bit different way of doing it. There we go there. Now I'm going to change the color. We'll go purple this time. And we'll start our simulation and see what happens. And there we go. Now there's my all on program. And let's see what happens when I push the button. It goes back to the bike light program. So you can see, there we go. So now when the button's on, it does one thing. When the button's off, it does another. What we can do here as well is I want you to share this project with me. Or share it with your teacher. So if you go into settings, there should be a share section. Descriptions, syntax, tags, access. So share a user, invite them to use the circuit. So just share me, and it's Travis.Burr is my 123D, my Autodesk Circuits thing. I might have to go all the way. Click invite, and it'll add me into your circuit. That way I can take a look and see what you've done. Alright, let's stop it there and move on.